Well, I know you guys are super stoked that I'm not there today. Check your Google Classroom for a couple of things. Obviously, some awesome music to start the week off of our theme from last week. But here we go, guys. 7.1 sampling distributions, the notes. I know that this is going to kind of suck, but because we already went over the German tank, this really shouldn't be that bad. So let's go ahead and think back to the Gettysburg Address activity that we did. It was probably at the beginning of chapter 6. That was the activity where I gave you guys the Gettysburg Address and I said, hey, randomly select some words. Let's dot plot the length. You guys did that. And then I said, hey, is there a better way we could sample? And you guys decided that we would number all of those words, which I had already done, and then we would randomly select samples to figure out the average. The average came out to be 4.28, I believe, correctly, if I remember correctly. But that was the Gettysburg Address, so hopefully you guys remember that. So what was the goal of the activity? The goal was that I gave you guys the Gettysburg Address, and I want you to estimate the word length, right? Kind of like we did with the battlefield. I said, here's a bag, let's estimate how many German tanks there are. How did we attempt to accomplish this goal? Well, we selected 5 words using a random number generator to select the words we were actually going to look at and count their length. And then we came up with some average for just that sample. So the average that we came up for just that sample is what we call the statistic, and we're going to call that X bar. So from this point on, we're going to have to make a very good distinction between X bar and mu. So if you're talking about a sample average or a sample mean, you guys need to be using X bar, okay? A parameter is a number computed from a population. So remember, what is the population? If we were talking about the Gettysburg Address activity, the population was the entire Gettysburg Address. We took samples of 5 words within that population to hopefully be able to tell me what the real average word length was for the Gettysburg Address, okay? So if we're talking about parameter, we're talking about population, you guys should now be using the mu as your designation for average, okay? You should also know that if I give you a mu, that I'm giving you the parameter. If I'm giving you X bar, I'm giving you the statistic, okay? So we're always going to use a statistic to estimate a parameter. We talked about this the other day when we were talking about the German tanks. Usually in the real world, the reason we would have a sample and not the actual thing is time, money, and the amount of energy and resources it would take to actually talk to, say, everybody in the United States. And so we take that sample and we get a statistic, and then we go ahead and use that to estimate what we think the true parameter is. So a picture of what we had the other day when we just took a sample of 5 words and we didn't take anything into account as far as sampling. So you guys took 5 words, you took the average, 5 words, 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 took the average, and so on. All of the groups did this, and I don't remember how many times we did it, but we all did it quite a few times. When we were done, you guys were the overzealous ones. You guys all took really long words and averaged them, which gave us a distribution that looked like this. We call this the sampling distribution of X bars because each little dot is one sample of 5, and it's an average for that sample, okay? When a statistic consistently overestimates or underestimates a parameter, what you guys did was you consistently overestimated what the true average was. If it was the reverse, if we had a whole bunch of data down here, you guys would be underestimating the true mean. We say that this is bias, okay? Bias. You're either going to overestimate too many German tanks, or in this case, word lengths are longer than they really are, or underestimate not enough German tanks, or, oh, my phone's ringing. I'll have to call Miss Tracy back, huh? Or in this case, we would have words that would be shorter than what the average normally would be. Okay, so bias is usually the result of poor sampling design. Our poor sampling design on the Gettysburg Address was that I just said sample. I didn't give you guys any parameters. I didn't um, tell you guys how to sample, nothing. Okay, so then how did we try to eliminate the bias in Gettysburg Address? Well, that was the second thing that we did. We actually took a random sample using Table D. So I gave you a sheet, all the words were numbered. Then you went to Table D because we were just learning how to use a random number table. And we selected the words that we were going to average. And this is actually the distribution that we got. And notice that the true parameter is right here in the center-ish. And we predicted it pretty good. A true simple random sample using a random digit table eliminated the bias in the sampling distribution. But how could I make the sampling distribution even better? Well, if I would take higher sample size, so we only took 5 words and looked at their average. Well, what happens if I take 10 words and look at their average? This curve would become more normal and the variability would then scoot in. Okay, so higher sample size reduces the variability. Remember, variability is how spread out this stuff. How variable is it? Okay, so it would take it and it would squish it back in closer to that 4.28. Okay, summary. What makes a statistic a good estimator or parameter? Low bias, low variability. Okay, now what you guys are going to do in class today, you're obviously watching this video, that's step 1. Step 2, in your groups, go ahead and do the check your understanding. Okay, upload these into Google Classroom before you leave class today. Okay, that's why the due date is at the end of class today. You can either write this by hand and then take a picture and upload it, or you could get a Google Doc, type it in, and submit it. That's fine also. And then, of course, your homework is right here as always. So hopefully we'll answer questions on this tomorrow in class. I will be back, and I'm not going to lie, I can't really remember how to turn the video off right now, so this might just run on for a few. I haven't made a video for a while, so yeah.